Hi guys, so today we're going to look at solving equations. We're actually going to split this up over 2 days. So today we're going to look at how to solve log equations. Then next class we're going to look at how to solve exponential equations. Part of that is going to need logs in order to be able to solve them. So that's why we didn't do it earlier in this unit when we were looking at exponential functions. So in order to solve log equations, you guys are really going to see two main styles of equations. You'll have logs equal to a number, or you'll have a log equal to another log. Now these first two examples, I'm going to go ahead and work out with you guys, and then you'll see it kind of cut into a different video. It's still going to be the same examples that you have on your notes though. You'll also notice there was a typo in one of those questions in your notes on Schoology. Should be a plus and not a minus. All right, so whenever you have a log equal to a number in this format, what we want to do is write this in exponential form. So in this case, this would become x squared is equal to x plus 6. Now I have a quadratic equation, so I'll set it equal to 0 in order to be able to solve it. So that's going to factor into x minus 3 and x plus 2. So I end up with x equals 3 and x equals negative 2. Now, as we've done all year, we need to always plug our answers back in and check for extraneous solutions. Whenever we check for extraneous solutions, there's two things to look out for. One, we need to make sure that our argument is positive. Two, we need to make sure that also our base is positive. Now, typically you'll be given the base. This is kind of an unusual example where the base is an x value. But in this case, if I were to plug negative 2 in for x, I would end up with a negative base, which I can't have. So my only answer here is x equals 3. All right, looking at the next one again, I'm going to write this in exponential form. So 25 to the negative 1/2 is equal to 2x plus 1. So remembering our exponent properties, negative exponent would move this to the bottom. And then 1/2 as an exponent is the square root. So that becomes 1/5. And I guess technically, I apologize, guys, that would also be 1/2. But square root of 1 is just 1, so making it a little easier for us. So then from here, I can go ahead and solve, so I can subtract 1. So that would be 1/5 minus 5/5 equals 2x. Divide by 2. Let me go ahead and subtract. So that'd be negative 4/5 equals 2x. Divide by 2, and I get negative 2/5. Now again, I need to take that value, plug it back into my original, and check to make sure that it's not an extraneous solution. So even though this value is a negative, it's not an extraneous solution because if I were to plug it back into the original, if I do 2 times negative 2/5, that's negative 4/5 plus 1, that's a positive argument. So since the argument is positive after I plug it back in, that's okay. It is not an extraneous solution. Okay, so the remaining examples are going to be on a separate video that this is going to blend into in just a second. Hi guys, so today, and actually this whole week, we're really going to switch the focus to solving equations. We're going to look at both log and exponential equations. Now I know we did exponential stuff earlier, but we wanted to wait until we learned logs to actually solve exponential equations because you'll need logs for them. But that's what we're going to do on Thursday. So today we're just going to look at how to solve log equations. Now typically log equations come in two forms. You either have a log equal to another log, or you have a log equal to a number. And depending on the format you have is the way you need to solve it. Now, typically though, no matter what kind of log you have, a really good strategy is to use your properties for condensing those logs together. So on this first one, I know those two logs on the right can be rewritten in a different form. So what I can do first is I can move 2 to be the exponent. So that would become 4 squared. And I also know if I have two logs that are subtracted, I can divide the arguments. Well, then at this point, if you have two logs with the same base that are equal to each other, then at that point, all you need to do is set the arguments equal to each other. Now, that's the only way that these will be equivalent. So at this point, x minus 4 is equal to 8, and I get that x equals 12. Now, just like it was with every other equation we've done so far this year, you need to make sure you check for extraneous solutions. Particularly any solution that gives you a negative argument. Those will be your extraneous solutions. All right, now let's look at this next one. This one's a little bit different because as you'll notice, it's not a log equal to another log. Okay, there's just a single log and a bunch of other things. So what I'm going to do is I'm going to get this log by itself. So I'm going to start by adding 7 dividing by 2. And now at this point, because it's not a log equal to another log, I can't just set the arguments equal. I cannot just do 2x minus 1 equals 11 over 2. That's not true. But what I do know is I can rewrite this in exponential form. So natural log has a base of e, so e to the 11/2 power is equal to 2x minus 1. Well, then at this point, to solve for x, I can add 1 and divide everything by 2. Now, it's not a very pretty answer, but if you want the exact answer, you could just plug this into a calculator to get it. All right, so again, let's just look at 2 more here. Again, if you can use those properties to condense, use those properties to condense. If you have a log equal to a log, you can just set those arguments equal. So looking at this first one, I can combine those 2 logs together on the left by multiplying those arguments. So this would become the log of x plus 2 times x minus 1 equals 1. Well, let me go ahead and FOIL that out just so it looks a little prettier. This would be x squared plus x minus 2. Well, now I can write this in exponential form. So there's no base listed, so that base is 10. 10 to the first is equal to x squared plus x minus 2. Well, it's quadratic, so I need to set it equal to 0. So x squared plus x minus 12 equals 0. Then I can factor, and I get 2 possible answers. Only problem is here, -4 doesn't actually work. If I plugged in -4, actually in both places, it only needs to be true for one of them, but if I plug in -4 here, that's the log of -2. I can't take log of -2. You cannot have a negative argument for your log. So that's not possible. So your only solution here actually is 3. All right, then let's look at example 4. There's actually 2 different ways you could work this out. I'll go ahead and do what I think might be easier for most of you guys. I'm going to move this log to the other side so that all my logs are together. Well, if you're subtracting logs, you can divide the arguments. So I can rewrite this as log base 2, x minus 3 over 3x plus 1. Now I can rewrite it in exponential form, so 2 to the third, so 8. And then I can just solve this rational function, so a rational equation. So I can cross multiply or multiply both sides by 3x plus 1. I get x minus 3 equals 24x plus 8. Don't really have a lot of space here, sorry about that. That would give me a negative 23x is equal to 11. So x is equal to a negative 11 over 23. Now the other way that you could work this out, I'll go ahead and put that at the top, and I'll erase that box. I don't know why I made that take up half the slide. Sorry about that, guys. All right, so another thing that I could do here is I can actually rewrite the number 3 with the same base. So these are both log base 2. Well, if I want all of these to have log base 2, I can rewrite 3 as log base 2 of 8, because that is 3. If I were to evaluate that, 2 to the something power is 8. 2 to the third power is 8. So that is equivalent. So I can rewrite this expression, and now I can solve this equation. So I can combine the 2 on the right by multiplying. And now I have a log equal to a log. So I have x minus 3 equals 24x plus 8, which is probably going to look pretty familiar to you guys because that's the same thing that we had down here. Solve that and you still end up with the same answer. X equals negative 11 over 23. All right, now I was so hurried to try and get you guys to see the extra method of doing this, I forgot to do the very last step, which is check to see if your answer is extraneous. If I plug in negative 11 over 23, negative 11 over 23 minus 3 is a negative number. I can't take the log of a negative number. So this is an extraneous solution. So the only solution that we found is extraneous, which means this actually has no solution. So no matter which way you choose to work it out, you're going to end up with no solution. All right, so again, today, like I said, we're just going to focus on log equations. You'll really kind of see these two forms. A good step, if you can condense any logs, condense them. If you just have a log equal to a log, you can just solve the arguments. Otherwise, rewrite it in exponential form. So for today, again, pretty similar. You got your practice problems, and then you'll have that week 6 assessment. It is going to have those exponential equations on there as well. If you have questions, you can fill out the video request, email me, or jump in that Zoom session.